Hello. So in this video I am going to explain about series and parallel combination of resistors. Alright. So in series combination, resistors are connected through a single path. They can be connected like this. There can be more resistor. In fact, if in a circuit there are resistance arranged like this, still because path is same, these are series combination. In parallel combination, they branched out from a common point and then again join at a same point. So in fact, if I draw it like this, still they are in parallel combination. So but the question is, if there are these resistors arranged in series combination or parallel combination, how are we going to simplify the circuit? What will be the value of resistor? Net resistance. Will it be always the normal addition of all the resistances or not? So let's check it out. So I'm taking a condition, I'm taking 3 resistors. There can be 2, there can be 4, there can be more than that, but I'm taking 3. And potential difference applied to the circuit is V. And if there are some resistors, so according to their overall resistor, there will be some current also. Let us suppose I current is flowing through the circuit. This resistance is R1, this is R2, this is R3. They can have same magnitude, they can have different magnitude. Now if this current I flows through R1, it will not get decreased. It is a basic misconception that this current will be decreased. No. Current, only that amount of current get released which can flow through the circuit. It is pre-decided. Already there are 3 resistors in the circuit, so according to that only the amount of current will flow, and that will flow through this and this in equal amount. So if there is 10 ampere current uh, emitting from this positive terminal of the cell, then the 10 ampere current will enter into from this negative terminal. So current remains same ultimately, because path is same. For the flow of current, path is same, and hence current remains same. So in series combination, current remains same, whereas potential difference is different. It is not mandatory that it will be different, but First thing, it is different from the source voltage. If there is 10 volt, this resistor cannot have 10 volt across it. It will consume less than 10 volt. So let us suppose potential difference across each component is V1, V2 and V3 respectively. Then one thing for sure is V is equal to V1 plus V2 plus V3 according to the law of energy conservation. V potential difference is supplied, so it some of the potential will be dropped across this, some of will be dropped across this, and rest across this. Now we know that from Ohm's law. Okay, this is just the side note. You have to put in the exam. You have to write it down, but it is not in the main derivation part. It is just the explanation. From Ohm's law, V equal to IR. So V1 equal to IR1, V2 equal to IR2, and V3 equal to IR3. Remember, I is same. So IR is equal to IR1 plus IR2 plus IR3. If we divide entire equation by I, we will get R equal to R1 plus R2 plus R3. Now many of the student will say, this is what we are saying. Yeah, but when we will solve this parallel combination, then you will get the answer. What are the basic outcome from this series combination? First thing, in series, current will remain same. And second thing, resistance will be the sum of all the resistors. Now in parallel combination, again I am taking 3 resistors. V is the supply potential difference. I current will flow, will be emitted from this source, this cell. But here we have 3 different paths. If I current is coming, it can't be I. From one I there cannot be 3I. And I'm not saying that it will get equally divided. It can be, but I'll say that here I1 current will go, here I2 current will go, here I3 current will go. And then once again, I current will return back. So in this case, remember what is potential difference? It is according to definition, amount of work done in moving unit positive test charge from one point to other point. Between 2 points. It is between 2 points. It's 2 points. It's 2 points. It's 2 points. All of them are common. So whatever be the potential difference across this will be the same for this, will be the same for this. It means in parallel combination we remain same, and that is equal to the source. That is equal to the source. Source voltage, source potential difference. But current will be different. Remember, this is subjected to a condition. It can be same also. but same among them. Okay, so when we'll solve some numericals, some kind of circuit problem, then you will come to know what I am saying by this, why I put this start over here. But that's for sure that in series current is same, and for parallel potential difference is same. I is different conditionally, so I is equal to I1 plus I2 plus I3, and once again from Ohm's law we have this V equal to IR. So I equal to V upon R. We can replace it here. V by R is equal to V by R1 because V is same, plus V by R2 plus V by R3. We can divide this equation, entire equation, by V. So there will be 1 upon R, 1 upon R1, 1 upon R2, 1 upon R3. Remember, so this is how we can say, not all the time if there are resistors, we can't add them all randomly, arbitrarily. We have to see whether they are in series or in parallel, and then we can solve them accordingly. Now let us suppose we have given this question. There is no cell attached here, but two terminals have been given. So it means when we are going to connect a cell, we are going to connect them across A and B. Hypothetically, there is a cell. Such type of question can also come where there is no complete circuit, but a part of it. So here we have 2 ohm, 2 ohm, 3 ohm. The question is, find equivalent resistance. They can write find total resistance, they can write equivalent resistance. Step 1, mark them R1, R2, R3. Step 2, explain R1, R2, R3 are in series. So R is equal to R1 plus R2 plus R3. Then solve. There are some students who can see this and they can directly write the answer 7 ohm. Yeah, of course, if such type of question comes in MCQ, they are correct, but in the exam they have to show this entire process, which is not that much long. This is a sensible way to answer the question. Now another same type of question I can give. This time I'm giving a battery attached. Okay, I have given a formula for 3 resistors. I have connected only 2 here, 3 ohm, 6 ohm, and there is a cell also which delivers a current which supplies a potential difference of let us suppose 10 volt, much easier to calculate. So the question is, find equivalent resistance and current through each resistor. Find current through each. Okay, so equivalent resistors. Step 1, mark them. Oh, sorry. Step 2, Identify the combination. R1 and R2 are in parallel. Then apply formula. 1 upon R12. This is my way. You can directly write R. 1 upon R12. 1 upon 3 plus 1 upon 6. Don't ask me what I have done. 3 by 6, which is 1 by 2. See, now right in the next step, what student usually do, they just write it 2 ohm, or in fact some of them are so excited they write here. No, that's wrong. In the next step, after this step, write the next step, reciprocate it, and here also 2 by 1, that is 2 ohm. Now you are eligible to write it in